So the plan for today is we're going to finish off the Chapter 1 homework discussion. So we've got to talk phylogeny and comparative method and all these kinds of things. And then we will start into Chapter 2, which I posted a couple days ago, I think, maybe Sunday night, which is, it's titled The Integrative Study of Behavior, but really it's sort of a using birdsong as this focal piece to look at these different levels of analysis we were talking about in Chapter 1. So that is the developmental mechanisms and neural mechanisms and adaptive value and evolutionary history. On the syllabus, we did have a quiz scheduled for today. I'd kind of forgotten I'd done that. That was definitely the optimism of writing the syllabus before classes start. And I'm just like, wow, this would be great. We'll get a quiz on the second week and we'll just rifle into the semester. And we didn't even finish Chapter 1. I didn't mention it last week, so I don't really feel like it'd be appropriate for us to do a quiz today. And I also don't like to do quizzes on Thursdays because typically, at least right now, you guys already have a homework due. There's oftentimes a lab going on. So I'm just going to push everything until that quiz until next Tuesday. And so next Tuesday there'll be a quiz. It'll be on Chapter 1 and probably whatever of Chapter 2 we get done. I don't know if we'll finish Chapter 2 this week as well, but it might be like the Chapter 2 lecture and not the homework, for example. Okay? It'll still be the same length, same points. It's just these are meant to be kind of ways to keep you up to date and assess how you're doing and have you guys know how you're doing in terms of progress through the semester. Thursday, we do have a Chapter 2 homework that'll be due. Lab, the plan was originally, and if it was going to be, the weather was going to be like it's going to be this afternoon, we were going to be at Prince Gallitzin. I did look at the forecast, and basically the one horrible, awful-looking day in our next 10 days is Thursday. So, and it's like peaking right at 2 o'clock, which is right when we would get there. So I mean, I'm kind of inclined to do it. It's not so much that I'm afraid of getting wet or that I don't want you guys to get wet, but if it is wet, then the animals just kind of go hide and they don't do anything, and the lab's a complete bust. So I've asked, we're going to reschedule our reservation for the rental minivan and such for the following Thursday, and we're just going to swap that around. So if you look at our syllabus, we were going to be doing day 2 of this Observe and Quantify Behavior lab, but instead what we're going to do is we'll swap that for this one. So this is a Mesquite lab. This is largely a computer-based lab. And I think it is good to do it early, and we're talking about phylogenies in this homework discussion today and a bit in the lecture that we're going to get into. So I think it's going to be useful, and I did want to get into phylogenies early anyway. So this actually works just fine. So we will do the phylogeny lab this week. Goose lab, or that's not goose, but I don't know, it could be geese. We'll see what we see. But that lab will be next week. So there will not be a lab report that day. Probably, if anything, the lab report will get pushed back a week as well. Okay? And that's assuming it's not a complete bust next week also. But, you know, I think there's a better chance that we'll have actually something interesting to look at next week than if we go and it's pouring and thunder and lightning and such this week. That's pretty much my plan. Any questions? All right. Yeah, I want to go play around in the park this week too, but we'll get there next week. Should be good. Okay, so where we are is we had finished talking about some of the questions from Chapter 1 homework. I think we got through number 3. So we finished talking infanticide. But what is left then is to talk about these questions about comparative method and ways that we test adaptive hypotheses, which includes comparative method, but also can include direct assessment of costs and benefits and that kind of thing. So let's see. I think where'd it go? Here it is. So this one, this was sort of a separate box, but this one went to Megan, and I should have asked you to do this for like right now, but would you be up for like sketching out what you got as far as a phylogeny goes? And I don't know if any of these markers work. That's not too bad. Yeah. while we're doing that, I'm going to pull it up. No. All right. Thank you. So, so this one read, we're going to complete the outside the box thing. So basically, which two species are the least closely related to each other? This is after they added these two additional species with these two additional sequences. Redraw the tree using two additional species below, and then determine which species are now the least and most closely related. So which ones did you, wow, I just had puberty. Which ones did you think were the most closely related and least closely related of these groups? These guys? And then, how about least closely? X and Q. Yeah, so these would be least. They may have a different tree or a different answer for those. Okay. Do we all agree R and Y were really closely related? Or the closest related? What's the basis of that? I mean, like, why did you pick out R and Y? Well, but versus each other, like, how do they compare to each other? Is there one difference, or are there two differences between those two? One difference between them. Yeah, okay. So, I mean, that really, I mean, we're kind of basing it on this idea that all things being equal, assuming no selection, which is a big assumption, we tend to assume that those individuals that are the most closely related should have the most similar genes. I mean, that should be pretty straightforward, right? And so, therefore, if we find a situation where there's, in this case, there's only one base pair substitution, they're probably really closely related. Whereas these guys probably have a whole bunch of differences between them. It's been a week since I looked at it, so I don't remember how many there were, but I remember that, some of them had dramatic differences between them. Tyler, do you have an alternative?
I do have Y and R as most closely related.
Yeah.
And it might just be the way I have mine set up. But
Yeah.
I have Z and R as the least related.
Z and R. Okay. How many, I mean, we could do this game, right? So we could count. It's really hard for me to do this on the screen because the stupid thing's on 2 pages, but
Mine more closely like it was in the book, where it was going line straight up.
so this is what was in the book. And then if you're going to be going through here, so like if you find that R and Y have only one base pair substitution between them, my inclination is to kind of tack on R right there. Well, I should have drawn it differently, but it'd be kind of like that, right? So that would indicate that these guys are really close together. And then the other new one was, what was it? Q, thank you. And so how does Q look compared to these guys? Is Q similar to anybody?
Q splits off with Z, and for the first branch, it splits off with Z.
Yeah, so Q goes GTT. I wish I could have these on the same page, but my ebook doesn't work this way. GTT, GTA. Good grief. Ah! No. GTT, GTA, CAT, GTT. So there's, I think there's one difference there. So they're pretty close. So shoot. I'm sorry, I should have brought my pre-drawn thing in here so I could sort of talk this out on the fly. But it does sort of indicate these guys should be grouped together, I think, based on their similarities. And that's what you're saying too, Tyler, right? So Q and Z might be together. Yeah, I mean, there's two different things here. I'll show you, and because I didn't bring my answer key with me because I left it in my office. There's two different ways you could potentially draw this, and I'm going to just point out these are actually saying two different things. So if you grouped Z and Q together like this, that would indicate that these two are more closely related to each other than either of them is to these guys over here. So like, because this is time. So this would be saying that there was one divergent event here that split Q and Z from X, Y, R altogether. And then out here, then there was one more split between X and then the YR group. And they went off in this direction. This is not quite saying the same thing. So this one, and you know, I'm even going to redraw this one in the same sort of style. Technically, this is what this one is showing. Q, Z, R, Y, X. So this is saying, and I'll show you, both of these are saying the same thing. So this is the common ancestor. There was a split early on where Q kind of split off from everybody else. So that would mean Q is kind of an outgroup. It would be the least closely related to anything that's in this group. And that Z, R, Y, and X are all kind of a group. And then here, this is saying that after that happened, then Z split off on its own, leaving this R, Y, X group. And then X split off on its own, and then that left to R and Y. Okay? So this part is pretty much saying the same thing. I know they're drawn differently, but these kind of can flip. I mean, the key thing is, like, where are these nodes? Where are these divergent points? So at this point, like this whole part up here, these are kind of saying the same thing. Does that make sense? Do you see that? So what's really, it's different is are Z and Q their own little group? Or is Z actually fitting more with these guys and Q is just totally off on its own?
You might see because the way I had it displayed in that one on the far right, I flipped Z and Q.
Well, yeah, but that doesn't really, I mean, all that's saying is that Q and Z split off from each other, so it actually doesn't really matter which way you draw them.
That's the reason
between those two.
Z and R.
Yeah. So I don't know, what do we think? Do we think Q and Z are their own little group, or does Z kind of group more with these guys and Q is off on its own? What's your feeling on that? Not sure? Okay. Yeah. So if there's Q. So if you look at these sort of key differences in Z versus X at least, I'm just going to put them sort of by position. So position number 1, we have a G. At position 5, these are the red ones. We have a T. At position 7, we have a C. And position 15, we have a T. If we flip over to Q now, position 1, it's got that G. Position 5, it's got that T. Position 7, it does have the C. And then position 15, it has the T. So it does have these sort of novel innovations that clearly group it with Z and away from X. So I would, I know there's at least 1 or 2 base pair differences between Q and Z, if I remember. I mean, do you remember how many? Anybody have it like right in front of you? It's just too cumbersome for me to do it. I think it's like 1 or 2. Yeah. So Z and Q seem to actually be really similar to one another. And they're quite different from X. X is in this whole complex up here. So I would kind of be biased towards this tree, where we're directly grouping Z and Q together as sort of their own little entity. Is that fair enough? These are estimates, though, right? I mean, what we have are genetic sequences, and we're assuming that the most likely scenario is that the most closely related individuals have the most similar genes. That doesn't have to be true, though. Like, there are ways in which that could not be the case. But generally speaking, mutations kind of accumulate at a steady rate. And so we can assume that this at least gives us sort of a good foundation. This is a good starting point where we would assume that the more similar you are, the more closely related. And the more distantly related you are, the less similar you should be. So this is kind of foundational. We're going to be doing some stuff like this next week also, this week also when we get to lab. But I think it's really important that we figure out and be comfortable with the use of these phylogenies, because once we do this, once we have a phylogeny in hand, like we do in a little bit on this homework, then we can start to try to infer how traits evolved or how behaviors evolved in different scenarios. And so I think they are a really powerful tool for us. So in that way, doing this phylogeny lab on Thursday is going to be a really nice sort of fluid thing that'll fit very tightly with class. So are we good with this one? Any other comments on question 4? Okay for now? I think when we get to the lab, it'll also, if you're still fuzzy on phylogenies, it'll give you plenty of chances to practice with them. In the meantime, let's move on to number 5. So this one we kind of broke up into 3 different, there's sort of 3 different questions. It's a huge question otherwise. Because there's 3 different experiments or different studies that are described in here that allow us to assess this hypothesis that mobbing is a predator distraction device. And that anybody ever been mobbed, out of curiosity, by birds? I haven't gotten assaulted by gulls, and actually really it's not even really mobbing, but at Prince Gallitzin in nesting season, there's a lot of little bluebird boxes all over the place. And actually the bluebirds are fine, but tree swallows also nested them. And tree swallows are these just spectacular birds. They've got this really bright blue sort of iridescent sheen to them. They're gorgeous, but they are not happy with you if you get close to their nest boxes. Have you had this? Like they will skim by you. They'll do everything they can just to like make your, get you paranoid, because they will dive bomb you constantly. And just sort of harass you until you walk away from their nest box. That's not really mobbing because there's not more than one individual doing it, but it's a similar kind of phenomenon where they're sort of distracting a predator and making it unpleasant for the predator to be anywhere near their nest box. So doing, they're helping to protect their young, apparently. So that's the hypothesis here. And so these are 3 different ways that we could try to assess this. And the first one asked us about this test done by Kruk, or maybe it's Kruk. I don't actually know how you pronounce that. Summarize figure 1.7, which I could pull out if we need to. But Gracie, what did you put down for this one?
So I put that the chicken eggs are placed outside and inside the black-headed phylogeny in an area, where after the eggs they typically get them and they found that the eggs that were inside the colony were less likely to be taken because the black-headed phylogeny would protect them, and it was an experimental approach.
Why do you say it's an experimental approach? I agree with you. I'm just...
Well, for me, it wasn't really comparative.
Right. Yeah, one species, no phylogeny. I'm just going to put, you're directly assessing the thing that you're trying to, you're directly assessing the hypothesis, right? So the hypothesis predicts that eggs should be taken less often if they're inside the defended boundaries where mobbing is taking place, and so you're directly assessing whether or not that's true. So that makes an experiment. I mean, makes it an experiment. We agree, disagree? Is that okay? Yeah, I think that one's pretty straightforward, but I kind of always like the idea of doing that experiment. If we just had like a gull colony nearby, I think that would be a fun lab to do, because I think that's a pretty feasible one. All right, number 2, or B, number B, concisely explain how the example of kittiwakes is used as a test of the predator distraction hypothesis. So this one went to Kayla. Where'd you go there? So you're comparing across species within a group. So I embellished what you said a little bit, but this is what I wrote. So, because I think this is what we were saying. So kittiwakes do not mob. They do, however, nest on cliff sides where there is very low predation. Therefore, with a different environment, they have lower predation risk because of these cliff sides, and therefore do not mob. This is a comparative approach because we are comparing multiple related species that live in different environments. There was another word that kind of went with this, right? And you might have seen it. I don't think I really threw it in here, but we did show it on the slides, where if you're comparing within a group, so you've got reasonably closely related species, but then the environment is different between them in a way that changes the selection that you think is causing a behavior, and you see differences in the behavior. You guys remember what that term was? I mean, I threw it out at the end of the last lecture. This would be an example of divergence. That's what I'm shooting for. So divergence is where you see this change, this difference, this divergence in the behavior. And again, it's caused because the thing that was motivating mobbing behavior, which has some cost to it, I mean, you're risking yourself if you're going up against some big predator. The parents are putting themselves at risk. It certainly takes some energy. So the benefit has to outweigh those costs. In this case, with the kittiwakes, once they get on a cliffside, there's really no benefit to mobbing because there's very little predation that can even get to them. I mean, they're like these incredibly sheer cliff faces. They're just absolutely crazy to see where they're nesting. Did you read the thing about the eggs? I think that was in there. Like their eggs are a certain shape. They're like really sharply slanted and narrowed. It's like a really extreme egg shape. So if they start to roll, they roll around in a circle, which is really good so they don't roll right off the cliff. So there's all kinds of other cool things about kittiwakes that allow them to exist on these incredible cliff sides. They have pretty sharp claws for a seabird, so they can grip onto these surfaces as well. But again, because they don't have predation, there's no benefit to mobbing, and so they just don't mob. You can pretty much walk right up to them and they won't be terribly reactive to you. I don't know what happens if you actually reach in their nest, but they don't go crazy on you like a normal gull will. I'm going to write. So this is an example of divergence. You have environment changing and resulting in differences in behavior that are consistent with our hypothesis about the function of that behavior. What about this last one? So There were two other examples that were given. There was one example of colonial nesting swallows. The other one I actually like better is the California ground squirrels. And these were used as a test of the predator distraction hypothesis. So, who was this one? Sorry, Jackie. You give it Jackie, right? Yeah, so what did you put for this? I know this is not what you said, but I'm just going to write it up here. So this is like you said, it's a comparative example. We're comparing across species. And here we're looking at unrelated species. So we see three now examples of unrelated groups that have similar predation pressures. They're all experiencing predation. They're all ground nesters. Their young are basically there for the taking. And so they all seem to be adopting this similar anti-predator behavior, this mobbing behavior. So this is good support for this anti-predator, predator distraction hypothesis for why animals will mob. And then, like I said, there's this other term. So instead of divergence, do you guys know what this one would be an example of? This is convergence, right? So you've got unrelated species that are all doing the same thing under these similar kinds of conditions. Why do you think it's important? I'm making this point over and over again that these are three unrelated groups. Why is it important that they're three unrelated groups for these purposes? I mean, what would you say if somebody came along and they said, well, I've got 3 different species of gulls, and they all are ground nesting and they all mob. So that's also really good support for this predator distraction hypothesis. What's wrong with that? Or why is that less good than this, where we've got 3 unrelated species? Any ideas? Seeing blanks, so you got an idea? Right. Yeah, so the common ancestor of a squirrel and a swallow and a gull probably didn't mob. But the common ancestor, if we were just looking at gulls, the common ancestor there may have mobbed. And so you've got, instead of you having like 3 different examples, really, where we've got 3 mobbing species that are all kind of like have this independently evolved mobbing behavior, if you're just looking at gulls, they might all mob because they just got that from their ancestor. And so you really don't have 3 examples there. You kind of have 1, right? It's just it evolved once and it's been retained in 3 different species. Whereas here, we've got 3 different groups that have all independently evolved the anti-predator behavior under similar kinds of conditions. So this is a much stronger argument because we've got 3 kind of independent events now instead of potentially just 1. Does that make sense? So it is really nice. This is one of the things that we try to do with comparative method is I think examples of convergence are really, really helpful because they do allow us to get this to build this data set that is sort of repeatedly arguing, okay, whenever this condition happens, your young are basically just ducks sitting on the ground or in a little tunnel waiting to be attacked by a predator, then mobbing is a likely behavior to evolve because it has such good benefits in terms of preventing mobbing or preventing predation. I do have some video, just because I get a kick out of these little guys because they're absolutely, in my view, just absolutely crazy. Bless you. Oh, where is it? I'm in the wrong chapter. Hang on. So, I don't know. I'll just show a couple videos here just to illustrate what's going on. This is maybe not the best of the pictures or the videos, but I'll show it to you anyway. But what we have here, no, don't do that. So what we have, there's an osprey. I think it was an osprey. It's a little short. But it's some kind of raptor. And it's kind of not the best video, but you can kind of see there's some gulls that are sort of zooming around it. I wish the person that did this video is zoomed out a little bit so we could really sort of see. But these gulls are just going after them. And you'll see this around here with red-tailed hawks and crows. Crows are pretty good at mobbing red-tailed hawks. And so you'll see this red-tailed hawk, which has about a 2-to-1 size advantage on a crow, but it'll be being chased by 2 or 3 crows and it's getting away. Yeah. Yeah, you will see. I mean, so it's not an uncommon behavior, especially very much with birds. And then here, these guys are great. So here's a little ground squirrel. You can see they marked him with a 3, so we can track who he is. And that's a rattlesnake right here. So this is what they do. And you'll see in a sec he kind of throws dirt on him. Come on, do it. He was sort of doing it a second ago, but it wasn't real dramatic. Here he is. Yeah, whoa, yeah. He didn't get lit, but it was close. Here's another one. So here's number 15. There's the snake. I mean, they just seem fearless. They're thrashing their little tail around. There, you can see the dust kind of flying at them. It's just really annoying. Did you guys ever watch Meerkat Manor? It's like a... Remember one day, I think it was a Thanksgiving or something, and they had just like this marathon on Animal Planet of Meerkat Manor. And there's a scene in there where one of the meerkats gets bit by a snake because he's doing the same kind of stuff. He's harassing the snake, and sometimes they do get bit. I mean, there can be really, absolutely fatal costs to this distractive behavior that they're doing. It's pretty incredible. I'll just point out there's other kinds of, sort of predator distraction hypotheses. I like this one. So this is where I just whacked this nest right now. I just love that they just keep coming. They're still coming. So they're not really mobbing here, but it is kind of a show of force. Right? And these are wasps that can especially attack.